So the ECTOF, it's an interesting product because it's a bit of a renaissance for GC, especially in fields of small molecule. For example, small molecule metabolomics, which is proximal to exposure sciences and exposomics. So it has dual ionization technology, so it's the best of conventional GC EI, but it also adds CI source, which is a really nice special kind of CI source that TOFWERK has developed, and they operate simultaneously, so you end up with rich EI fragmentation spectrum and CI molecular ion spectra, which help specifically with the discovery and the annotation of new chemistry. And we see new chemistry needs in things like microbial metabolism, but also exposomics. So it's really an important, I think on the biological side of things, it's an important technology. On the environmental side of things, we have collaborators in the field who are using that same technology to measure air quality and airborne pollution. So part of the airborne exposome is being measured. So it actually is a unique technology playing a role on both sides of this exposomics equation. I think the reason that real-time, or what we call high-time resolution, is so important compared to conventional offline sampling is that you can imagine if I have a wristband, right, that as absorbing to it all the exposures that I have, ultimately I can have that analyzed and I can see that my daily exposure was high, right? And daily might even be high frequency for exposome monitoring. But the thing it can't tell me is really anything actionable, right? So I don't know if that's been low level exposure all day long, or if that's been very short periods of very high exposure, which perhaps I could act against. I could make an informed choice to avoid a certain source or a certain type of exposure, right? So being able to measure the source of exposures, being able to understand the quantity of those exposures at those times, that's all really actually very important to how exposomics works. So our systems that operate at high time resolution and are also, we're able to, if we put them in vans, we're able to look at the geospatial location of things, right, to determine where sources of exposure come from. That's a critical key component that's just not kept if we have offline measuring techniques. That's interesting. I think the innovative thing that TOFWERK is doing is not only is TOFWERK capturing what's difficult to capture, but it's going beyond to what hasn't been previously captured. So, for example, the MIPTOF system looks at trace levels of metals in the air, and that's something that's of very high interest to our customers now because it's not in the normal routine measurement package of what people are usually looking for, but that's kind of the whole point, is that these technologies are shedding light on things that certainly are out there, but maybe it's not so known, right? So we have technologies that are able to reveal things in the airborne exposome that people should be looking at for research purposes, should be monitoring, should be perhaps regulating, right? So I think that's really the ultimate challenge, is seeing the previously unseen. What it will take to take exposomics more mainstream, first of all, I think a lot of it's being driven by public awareness. Public awareness in environmental sciences has become huge in recent years. Things like indoor air pollution, of course, PFAS in water, right? These are things that were big and have been addressed somewhat, partially addressed in recent years. But the airborne exposome, right? People are just learning that PFAS are in air, and people are just learning that, for example, when we burn wood, we've seen recent publications that show that releases lead into the air. People may have thought, actually, I thought airborne lead was a problem that we did away with when we did away with leaded petrol, leaded gasoline, right? No, because that has now worked its way into the environment and we're re-releasing it, right? So public awareness through the measurement capabilities that technologies like TOFWERK are able to provide, I think that's what's really driving it mainstream. In the research communities now, you have interdisciplinary science teams working. You have epidemiologists who care about big, vast populations. You have clinicians who care about specific patient cohorts. You have environmental scientists who have been studying these things all along. And it's linking all of these different disciplines to go from exposure source to quantity to metabolic impact to health outcome. That's the exposure cascade. That's a real interdisciplinary science that we aim to enable.